to BKW Physics. I'm Mr. McConley. We have a series circuit set up right here. We're going to go through some of the laws that we just previously wrote down in our notes. And the first one we're going to check is that the I total is equal to the I1 is equal to the I2 is equal to the I3. So right now I have the total current reading 0.2 amps. I have another ammeter which I'm going to hook into the circuit here and see what it reads. And on this particular location, it's reading 0.2. So both the total and the I1 is reading 0.2. I'm going to move along here to the next location, and keep doing it backwards. That's my fault. I'm not paying attention. But on the next location, you can see, again, it's 0.2. And in fact, on any location in a series circuit, the current will read exactly the same thing. It will be 0.2 amps, because that's what the total current is. So we've shown that the total current is indeed the same all the way around. The next thing we're going to look at is the total voltage. Now, if I can have one of my assistants here plug those into the positive and negative of my source, so you can kind of just stick it in the end of the banana there. And in the end, that's far enough. It just has to get a reading. We can see that we are on, let me switch scales. It's too much. On the 15 volt scale, we're reading about 3.5 volts. Okay? So you can unplug those. I'll go check it someplace else. So that's the total. If I check it right here, I'm getting about 2 volts. I check this one, even less, maybe like 1.5 volts. And I only have 2 resistors in this circuit because that's a switch, and switches, if they're a good switch, they don't use any voltage. Okay? So I only have 2 sources of resistance, and you can see 2 plus 1.5. This was supposed to be addition. This is an addition sign. So when you add up the voltages, 2 plus 1.5 gives you 3.5. That checks out also. Now the last one we have to check is the resistance. And the resistance is a little bit harder because we got to do the voltage divided by the current. So I have an assistant that's going to crank out some numbers for me. So we have 2 volts divided by 0.2 amps, which gives us 10. We have 1.5 divided by 0.2.
7.5.
7.5. So in total, we should have added up 17.5 total resistance. And there is a way to check that with an ohm meter. I just don't have one on hand right now. So the other way we can check it is to look at these numbers and say, okay, 3.5 volts divided by 0.2 amps is
17.5.
17.5. It looks like it's checking out. All of our numbers we have shown kind of correlate to the way the laws say they should. So for a series circuit, we've gone through the total current, total voltage, and total resistance. Thanks, Sally. Physics.